Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Greater Efficiency with Intelligent Motor Control. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started today, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, ABB. ABB is a leading global technology company that energises the transformation of society and industry to achieve a more productive, sustainable future. By connecting software to its electrification, robotics, automation, and motion portfolio, ABB pushes the boundaries of technology to drive performance to new levels. With a history of excellence stretching back more than 130 years, ABB's success is driven by about 110,000 talented employees in over 100 countries. Now today we'll hear from 3 speakers followed by our live audience Q&A, so I encourage you all to please send your questions through to our speakers via the chat box. I'd now like to welcome our first speakers. Firstly, Dipyaman Basu. Dippy is the Product Marketing Director for Smart Power and Smart Building divisions for ABB in Australia and is passionate in engineering, design and very keen to create electrification solutions for applications in all segments. I'd also like to welcome our other speaker, Hussein Ahmed. Hussein is the Global Digital Product Manager in Electrification Division of ABB and has an extensive experience in digitalization and automation and has worked in different roles including program management, marketing, business development and software development and commissioning in a global environment since 1994. In his 22 years of professional career, Hussein has a global experience and has visited 30 countries in this quest. Please join me in welcoming Dipyaman Basu and Hussein Ahmad.
Thank you, Megan. So, the social, the economic, and the environmental changes in our world today have led to electrical plant owners requiring to reduce their carbon footprint and embrace automation and digitalization. In the world of motor control and protection, that basically translates to accurate energy monitoring and load management. And effectively being able to embed intelligence or motor control solutions help in centralized integration and control while efficiently managing multiple assets from the same platform. So today, we would like to take you through various scenarios and applications in the real world with our subject matter experts. So I will start with an overview of our solutions, which will be followed by Hussein on real-life applications, and Lee will shed some light on motor control centers and how they are future-proof. At the end, we'll take some questions from all of you and try to answer them as best as we can. And if we run out of time, we'll reach out to you after the webinar to answer those specific questions and continue the discussion. The big question that we have at ABB is what kind of solutions do we have and what are the different applications we can utilize these solutions? In terms of why we choose ABB solutions, we have mainly four main facets of our solutions. And what we're trying to achieve is for plant owners, one, continuous operation by reducing or eliminating downtime, service interruptions, while ensuring effective protection and monitoring. Then we have energy efficiency, optimizing power consumptions to not only save costs, but also to cater to various effects of temperature rise in electrical systems. With ease of installation of our products and accessories, we are able to be safe and we can reduce labor costs in panel assemblies with the various array of accessories and products that we have in the ABB portfolio. This also reduces human error and ease of speeding up projects going right to the field. And finally, we look at integration with advanced control and protection. So ABB's advanced solutions that we will talk about shortly will provide precise and flexible monitoring and control capability with the use of universal communication protocols. While this provides intelligence to predict failures and sustains assets during their life cycle, we're also able to provide scalability, and ability to plan for future expansion. So we spoke about solutions. So what do these solutions really look like? We mainly look at three main solutions which are catered to every application, scenario, and surroundings. Starting with essential, which is catered to standalone systems. Enhanced solutions, which are for more complex systems where multiple systems can have interdependencies. And then we have advanced solutions where we use data and analytics as well as digital technology to aid efficiencies to running plant. Let's look at the first one, essential solutions. The essential solutions ensure that the core power and devices work in coordination with each other while ensuring continuity of operation. These solutions typically cover requirements of standalone machinery like pumps, compressors, etc. Then we have the enhanced solutions, which is catering to providing robust protection while achieving enhanced control, safety, and monitoring for applications in the field. This includes being able to provide additional protection functions such as liquid level relay, twin pump alternate relays, temperature monitoring, thermistor motor protection relays, under voltage, over voltage, safety relays, and so on. In addition, this also provides the ability to be customized, and our experts are always working towards catering to various applications and addressing specific needs case to case. Finally, we have the advanced solutions. With the use of smart data and predictive applications, we are able to get ahead and be able to plan for the electrical plants to keep running. The advanced solution includes integrated and future-ready motor protection devices and control, giving flexibility to motor control as a whole, being able to fault diagnose, plan and predict maintenances, as well as utilize universal communication protocols within the systems to be able to look at everything holistically through a single platform. Now let's look at what these solutions actually do and how they cater to how they provide motor control. How they provide motor control in overall. Starting with motor starting and protection. ABB has a complete range and comprehensive range of products for motor starting products and services which provide reliable and consistent quality and performance. Products such as soft starters, which can increase the lifetime of a motor by providing protection for electrical stresses. We have our universal motor controller, which is called the UMC, which is an all-in-one solution for motor protection and control with the ability to fault diagnose. Further, we have a wide range of smaller products such as manual motor starters, contactors, overload relays, which are tested in coordination with each other, and they provide solutions to simpler formats of motor control such as DOL, star delta, etc. And these systems can further be monitored from a remote point of view through our cloud solutions and digital solutions, and help in being able to manage energy as well as the assets. Next, we have load management. So ABB offers various solutions to manage AC/DC loads with the ability to create customized logics to switch and control, enabling isolation and also signal separation. Few of these functions can be really crucial to accomplish the various machine processes. Few examples of load management can be transformer protection, protection for auxiliary circuits, capacitor switching, lighting control, and also managing AC1 loads. Next, we look at command and signaling. So when it comes to command and signaling, the human and machine interface requires a high level of safety, and which is what we're able to provide with a YOCAP safety offering. Whether we talk about sensors, switches, locks, gates, curtains, or safety curtains, which are used to control gates and hatches around hazardous machinery, and they also allow to monitor the position of the machine, providing a high level of trust to machine operators. Then next, we have different solutions that we have for switching and protection as well. Whether we speak about overvoltage protection for surge events such as lightning, we talk about residual current protection for accurate protection for people, and circuit breakers to cater to installations which require extreme or very high levels of braking capabilities and reliability. And then finally, we have measuring devices with the ability to connect onto the cloud to facilitate effective energy management. With that, I'd like to hand over to my colleague Hussein Ahmad, who will take us through some of these examples of solutions in real life applications. Thank you.
So thank you very much, DP. It's really nice to be here with you in this remote sessions, and I'm sure one day I will be there in Australia and have the chance to meet you in person. In the next slide, we are looking at ABB, what the applications ABB are providing for different segments and different solutions. This is starting with, if you can move to the next slide, please. Let's have a quick look at the motors. Being electrical and automation engineers, being somebody involved in the electrical and automation systems, we know that motors are everywhere, everywhere. So in European Union only, there are around 8 billion motors, which is definitely much more than the population of the whole Europe. In addition to this one, as you can see here in this slide, that 47% of the global energy consumption is done by the electrical motors, and 68% of electricity consumed by mid-size motors. Something very important is to understand that 80% of the motors are full speed motor application. That is the motors which are being switched on and switched off. This means if we manage our motors, if we manage to commission, install, operate, and maintain those motors, we are not only capable of optimizing our energy consumptions, but at the same time, most of our process will remain efficient and cost effective. In the next slide, we are looking at what we as ABB are offering. So we have developed solutions like DP has also mentioned in terms of essential, advanced, and enhanced to ensure that instead of reinventing the wheel, you can use our pre-developed, tested solutions to optimize and to maximize your not only the commissioning time but also the operation. Not to forget the energy optimization. These solutions, these bundles are built upon the requirements from you. We understand that you as customer, as you as doing the commissioning, and you being the operators of those motors, we know that your domain, you have your domain expertise, and we come up with our part, which is our electrical knowledge. So combining all these things, we can work together to develop solutions to manage motors um, in very efficient way by reducing the commissioning time, by having better maintenance, by having connected devices to the cloud, and to perform better analytics and monitoring. Next slide, please. As example, we are looking at application for HVAC. As you can, I would like to encourage you that please scan the QR code to find a detailed application note on how to manage different equipments in the HVAC. And as you can see here, we are offering a comprehensive solution right from motors up to 5.5 kilowatts with mini contactors up to managing motors to 45 kilowatts with MMS and our soft starter range. This means with our pre-developed solutions, you can manage different part of the HVAC and which can be being operated by different size of the motors. In the next slide, we are looking at next slide, please. So in the next slides, we are looking at essential, as already stated by DP, that essential means here we are looking at switching on and switching off motors without any external inputs or outputs. This means you may have motors in compressor, in fans, in an HVAC system, and we are providing solutions which are based upon number one, breakers, followed by contactors, and so on and so forth. This means subjected to the application, subjected to the requirement, a variety of possibilities are being offered to switch on and switch off motors in your HVAC system. In the next slide, we are looking at application for pumping. Again, I would strongly recommend to please scan this QR code and you will get this detailed document on how to manage pumping applications. When we are looking at the pumping applications, when we are looking at the motor which are driving pumps, we need to have two set of functions and features. Number one, electrical related, which we need to ensure that we have short circuit protection, overload protection, phase loss, and so on and so forth. But at the same time, and there are certain aspects which are related, which are specific to the pumping. For example, we have to ensure we detect dry run if the pump is running in dry run mode, or we are having some jammed or clogged pump, and we have to ensure that subjected to the requirement, the safety standards are being confirmed. Combining these two things, our solutions are based upon, like I have said earlier, not only to provide the electrical related functionalities, but also application specific functionalities. In this case, pumping, and then we are looking at clock pump and features like dry run or digital connectivity and so on and so forth. In the next slide, we are looking at how our soft starters can be connected digitally. There are two aspects. Number one, we can connect our soft starter to the cloud-based system, and at the same time, we can connect our soft starter to the PLCs and DCS with a variety of field bus, which includes Modbus RTU, DeviceNet, Profibus. And at the same time, there are address ranges to ensure that the PLCs and DCS and also the digital system get the parameters from soft starter, which can be voltage, current, power factor, if the pump is in dry road or if there is a clogging. So these parameters are stored in soft starters, and then the user are capable of getting this data in PLCs and DCS, provided they are connected to the soft starter over Modbus RTU, DeviceNet, Profinet, and so on and so forth. In the next slide, we are looking at enhanced solution. We have talked about enhanced is that in addition to the switching on and switching off the pumps or motors, we have to check that we have to ensure that there are certain other parameters which are taken care. For example, safety. We provide safety relays and which are capable of managing safety contactors. At the same time, in many applications, we know that a level has to be monitored and certain actions has to be performed subjected to the level and other parameters like pressure and so on. So in our solution, we combine not only the switching on and switching off the motor, but also taking care of the inputs like devices from the field for level, pressure, flow, and at the same time, safety related requirements are taken care of. What we are looking at is an advanced solution. In the advanced solution, we are saying that we can connect our pumps to different PLCs and DCS over a variety of equipment and field buses. Here we are looking at UMC, which is our motor controller, together with AF contactors. It can be with soft starters. It can be with breakers and capable of sending data or managing, exchanging data, I would say, with PLCs, DCS, and at the same time, cloud-based system. So what we will, our message is like this. These solutions are ready-made, they are tested, and then subjected to the requirement, we are providing a variety of sets so that the solution offer is optimized, not only in terms of reliability, but also in terms of the cost. Now, we are living in an era of digitalization. We are seeing digitalization everywhere, right from our banking system to our cars, and that's why we are seeing digitalization also emerging extensively in automation and electrical system. For this one, ABB is offering our flagship carrier, I would say, which we call ABB Ability Energy and Asset Manager. This platform, this is a digital platform which is being hosted on Microsoft Azure, and at the same time, it's capable of getting data from the device which are connected over Modbus RTU, TCP, over our standard edge gateway. So this platform is capable of is offering predefined, pre-developed widgets for monitoring energy, for monitoring parameters of individual devices and equipment. But at the same time, it is capable of generating reports, perform analytics, and in terms of when there are some events occur, this platform is capable of generating emails, text to inform the user that something abnormal is happening in your system. Here, we need to understand there is an interesting trend, which is convergence of IT and OT, which means information technology is converging uh, very rapidly with operation technology. So, what was considered to be the domain of automation engineers is now being shared by both IT and automation engineers. So with this one, we need to understand that the modern day equipment are having two parts. One is connectivity to the cloud for better monitoring and analytics. And at the same time, let's say the classical control system is still there. So we have to have control system to manage the equipment locally. This means switching on and switching off the pumps, switching on and switching off the ventilators, subject to the conditions like pressure, like air, temperature, and so on and so forth. But at the same time, we have to ensure that this data is being transmitted to the cloud-based system for better monitoring and analytics. ABB has recently launched what we call with the topic with the subject of a piece of cloud for everyone. We call it smart communication card. This smart communication card, which you are seeing in the middle of the screen as a blue box, is capable of on site gathering the data from the field over Modbus TCP, RTU, and OPC UA from the devices like energy meters, soft starter drives, temperature sensors, and so on and so forth. Then perform logics using a node rack based logic control, and then at the same time is capable of sending data to the cloud based monitoring system. I would like to emphasize here that we are capable of getting data not only from ABB devices but also from the devices from third parties. At the same time, this smart communication card is capable of sending data to any cloud-based system, provided that cloud-based system is supporting OPC UA, Modbus TC, I'm sorry, MQTT, and HTTPS. So looking at this one here, we are looking at an example of escalator, which we know that, again, I would like to repeat, consisting of two parts. One is managing the escalator motor, ensuring that the safety is there, performing certain logic that, okay, when there is an emergency condition, then the escalator should be stopped. There should be an energy saving mode enabled if the escalator is not running. And then at the same time, for the operators, we need to ensure that we send the data so that the operator can know the energy consumption, what are the faults, if there are any, which events occurs in a particular period of time. So as you can see here in this screen, on the field side, we are showing devices which can be connected over Modbus RTU, over Modbus TCP, and at the same time on the top we are showing some screenshot from the app, which are trends which are capable of showing energy and other parameters in tabular form, and also generate certain reports and send text. So coming back to the ABB ability, we know that motor control centers are also it's getting more and more important to ensure that um, we operate motor control centers and ensure that the data available for the remote operators, so that they can ensure not only the protection but at the same time reduce energy consumption, manage billings, and monitor health assessment and operation strategy. So with ABB Ability, we are offering a complete set of solutions there, including widgets, including those reports, features which enable the operator to remain in close contact with their MCCs, and thus moving towards IMCCs. So with this one, I would like to thank you and then hand it back to Dipi. Thank you.
Thanks, Hussein. So let's look at some of the key benefits of our products. Starting with our AF contactor range. This contactor range has built-in surge suppression, While the internal electronic system is continuously monitoring the current and voltage within the coil, this helps in enhancing the safety and allowing optimal running of the system while being harm free. With the built-in PLC interface, the AF contactor range also offers very low power consumption or very low power for PLC outputs. When it comes to steady operation, AF contactors have a wide control voltage range, and the capability helps in maintaining continuity of control circuits, allowing the different voltages to be used when you can which can prevent stoppages caused due to voltage fluctuations. With lower energy consumption of the AF contactors, we can also effectively reduce heat dissipation and temperature rise, which in turn can allow higher installation density in control panels. And of course, that leads to cost savings. When we talk about reliability, especially in harsher climates and conditions, when they cater to electronic products, this can be sometimes a challenge, which is why we have various products. And one of the products which have the coated PCBA cards is our power supplies, which are coated for assuring their performance in harsh and corrosive environments. And as you've seen so far, ABB have a wide range of products for motor control in its different aspects. However, the coordination, the use of these products with each other require coordination and require testing. So we have tested more than 1,800 different scenarios with the different products that we have and validated the results, which is quite easy to download and view through our online software tool called SOC Web. When it comes to a motor heating option, our soft starters have this special option which can be programmed in the pre-start of a motor. So what the soft starter does is passes a small DC current through the motor, enough to generate heat to allow removal of any condensation in damp and wet environments. And this does not start the motor. It's just to allow the condensation to go away. And this is an ideal option for wet and damp environments. And then we have the detachable keyboard, making installation easy and also saving costs and having additional accessories. When we look at some of the other specific features of our soft starter ranges, we have limp mode. So limp mode is an interesting feature that we have in our soft starters. What that allows us to do is continue to run the pump or the motor which the soft starter is feeding into, even if one of the thyristors has shorted and is not working. So this allows continuity of operation and allows for ability to plan repairs and schedule maintenance and so on. With also the soft starters, we have the option. Well, it's not an option; it's a standard feature to have a PCBA card coded. Again, for allowing lower risk of stoppages and issues that can happen within that particular installation, but also allowing reliability of the installation in harsher climates. With the help of the PT100 input, we're able to also trip the circuit when required, and the user can set the temperature where the trip needs to happen, right from minus 25 degrees Celsius all the way up to 250 degrees Celsius. And then we have, when we talk about planned or scheduled maintenances, ABB's enclosed padlockable solutions with our switches can isolate a motor or a motor control system during maintenance for safety of the operating personnel. And these switches have been tested for both indoor and outdoor use. With that, I would like to hand over to Lee, where she will speak about motor control centers which are future ready. Thank you.
Thank you, Dippy and Hussein, for your presentation and insights. I'd now like to welcome our final speaker, Lee Chen. Lee has more than 20 years of experience in low voltage switchgear business, including low voltage system application engineering, research and development, product management, intelligent motor control centers, and digital switchgear applications. Please join me in welcoming Lee Chen.
Thank you, Megan. Hi, everyone. So, in the next chapter, let's jump out of individual motor application and take a look at motor control centers. Let me share with you what ABB MCC is offering today and how it is set up for future challenges. First, let me start with the basic question: what is a motor control center or MCC? Although most of us may have heard or already used the term MCC, especially in communication with industry customers, the term has never been officially defined in any IEC standards. In low voltage system, it is referred as switchgear and control gear assembly as per IEC 61439. A motor control center is an assembly to group control, protection, and metering devices for electric motors in a centralized location. The first MCC was introduced as early as in late 1930s to save floor space and for the convenience of the operators. In a typical low voltage MCC, we usually can see one or multiple incomers with groups of motor starters feeding through to electric motors. Previously, my colleagues Hussein and Dipi have already discussed individual motor starter types, applications, and a new trend. Here, we're speaking from MCC perspective. We noticed from today's applications, more varieties of starter types are selected rather than one single starter type, DOL, also known as direct online. Soft starters, variable speed drives, are often in MCC integrations now. Requirements such as protection and control of high efficiency motors are also on a rapid rise. And type 2 starter coordinations is almost become a must to follow. All these changes tells us that MCC applications are part of the motor management lifecycle reshaping towards the next level of safety, reliability, operation efficiency, and sustainability. What drives the reshaping is the changes from today's individual customers' needs and also the challenges they will be facing tomorrow. Traditionally, MCC customers are from oil and gas, chemical industry, mining and metals, and water treatment plants, etc. In these industries, electric motors are critical access at the core of their operations. On average, electric motors account for between 60 to 95% of the electricity bill in a plant. And the motor failure rate, according to IEEE study paper published in 2019, can go up to 12% in some industries such as mining or pulp and paper, with an average of 3 to 5% failure rate across all industries. With recent decades of rapid growth of investment into infrastructure, transportation, as well as data centers, MCC is expanding quickly to these emerging segments which are constantly in high energy demand. All our customers today must face the ongoing increasing energy demand to support continuous growing business while adjusting to the tightening safety rules and standards and the mounting pressures to demonstrate sustainability practices for the government, society, and also for the investors. Internally, they must also face the challenges of lacking skilled staff or how to close a knowledge gap to embrace new technologies, etc. To manage all these challenges, all industries have been actively looking for solutions to improve plant efficiency, save energy, improving sustainability, and digitalization. Digitalization holds the answers today to all customers' needs, and the latest technology development under Industry 4.0 have already laid the path on how to tackle the challenges through digitalization step by step. During Industry 3.0, intelligent motor controllers have already been introduced in MCC starter with combined protection, control, and metering features, which significantly simplify the motor starter design. With the latest development on digital technology, we are now ready to add in more ladders and address the four main pillars defined under Industry 4.0. In switchgear MCC solution, these four pillars refer to collection information through few smart devices and various sensors, connection of devices and sensors through Ethernet-based digital networks, and then provide 24/7 online supervision for condition monitoring. And last but not the least is delivering solutions to improve the performance of MCC and assist customers through the complete life cycle management of the operation plan. Next, let's take a look at how ABB's MCC offering address all these four pillars and set the solution ready for tomorrow. So ABB low voltage MCC is based on M&S3 switchgear. M&S3 is a front access indoor switchgear which is rated up to 6,300 amps, 100 kA. It is a type-tested assembly to IEC 61439 and arc-proof tested to IEC 61641 criteria 1 to 7 to ensure high level of safety reliability among our market peers. As a motor control center, M&S3 offers a complete range of MCC solutions today, from conventional MCC with electronic overload relay to intelligent MCC built on ABB smart controller devices such as UMC 100.3 or M10X relay, till today's or current digital MCC solution. We offer combined or integrated solution of soft starters or variable speed drives in MCC. We also offer Type 1 or Type 2 motor starter coordination, not only for IE2 motors, but also for the high efficiency IE3 and IE4 motors. ABB M&S3 MCC started as early as 1970s and went through 3 generations ever since. The first intelligent MCC was built in the 1990s through long bus-based INSUM system. And the first ABB digital switchgear was then introduced in late 1990s, also known as MNSIS. ABB M&S3 has an outstanding design service life up to 25 to 30 years. The technology has been market proven with well-established reputation of high quality and reliability. As of today, ABB has already delivered more than 2 million M&S panels with nearly 500,000 intelligent motor starters globally. Among them, over 80% remain in operation today. So this demonstrates the reliability and quality offered by ABB M&S product. The intelligent MCC offered by ABB M&S3 today is a solution built on ABB Smart Motor Controller device, UMC 100.3 or M10X. The intelligent motor starter compared with conventional starter delivers significantly more values, especially on simplicity, safety, and functionalities. The example here is a quick comparison on the difference. Other than power switching device, most of the associating control, measuring, signaling, protective devices are replaced by one single smart controller. The example shows an ABB M10X relay in a typical M&S3 withdrawable module. Today's smart controller not only has the built-in motor protection control and metering features, it also incorporates remote I/O features, local fault recording and condition reporting, and powerful communication capability, and a lot more, thanks to the latest technology on the electronic chips and Ethernet communication. As mentioned earlier by Hussein, ABB offers cloud-based ABB Ability Energy and Asset Management, also called as EAM digital solution for MCC panel builder. Along with M&S3, ABB also offer on-premises digital solution, ABB Ability Condition Monitoring System, short as CMES. CMES offers monitoring and diagnostic applications at customer site. Most ABB MCCs today already have smart devices installed across the switchboard, from ACB's Smart Tripping Unit, Equip Touch, ABB Smart Motor Controllers UMC 100.3 or M10X, to various temperature sensors as well as environmental condition sensors, etc. The extensive amount of information collected by the smart devices and sensors are then reported to a data concentrator through Ethernet-based digital network, where correlated data are compared, studied, and analyzed. In M&S3, the data concentrator can be an ABB switchgear gateway device installed on a switchboard to provide centralized parameterization, automation, and control. The data concentrator can also be a CMES hedge to collect multiple switchgear information and provide applications such as 24/7 online condition monitoring for analysis and solution suggestions, energy consumption analysis and reports, etc. So the on-premises system is set up in a way to report the condition data to customers' planned solution data pool through the secure OPC UA link when it is required. All ABB digital applications are customizable and adaptable, not only to meet the customer's needs today, but also prepare for the future. Let's use two examples here to further elaborate how CMES improve efficiency. In the first example on the top is the health index part of the dashboard a user sees when entering the CMES. If all is green, the user can close the window and continue with other important tasks. If it is indicated, for example, a temperature problem through a color change, the user then can start assessing this by navigating to the second dashboard, a switchgear assembly or panel view that clearly indicates the location of the issue. As such, save the forward locating time and improve the operation efficiency. The second example, which is shown on the bottom, outline the difference of total repair time in minutes in case of a fault between a conventional switchgear and a switchgear with a CMES system. From fault identification, resolution identification, through preparation time of paperwork, identifying spare parts until the affected assembly is finally restored to operation. It is expected to save up to 50% of the full managing process with the application of the CMES, hence increase plant availability significantly. Our industry are closer than ever to digitalization. According to ABB's white paper, See the Potential of Digital Faster, which surveyed more than 300 industry decision makers across 7 markets and 9 industries. Up to 93% of the businesses are already on their digitalization journey, although only 21% have reached maturity and are getting all the benefits they can out of the industry Internet of Things. In ABB, our switchgear today are ready for digitalization to offer our customers safer, smarter, more sustainable, and future-ready motor control centers. So with this, I hand it over back to Megan. Thank you.
Thank you, Lee. Now, before we move into our Q&A session, I will just invite Dippy just to say a few words.
Thank you, Megan. And thanks everyone for listening. We wanted to let you know that we are embarking on a very exciting project, and we invite all of you to take part in. We're launching a survey which is to find out how important sustainability is in the context of Australian businesses, and what needs to change for it to be prioritized meaningfully moving forward. So the responses will be in form of a research report, which will be released in June by us, and we would love you to include your opinion in that research. The survey is quite simple. It'll probably take 5 to 6 minutes to complete. So please scan the QR code on your screens so you can take part on the survey. Thank you.
Thanks a lot for that, Dippy. Well, now it's time to invite all our speakers back in so we can have our Q&A. Now, we've received questions from registration. So again, thank you to everyone who took the time while registering for our webinar today. And I can see that we've had a few live questions come through. So let's get started. Now, the first question has come through from Michael Lucas. And his question is, what are the biggest barriers to adoption of intelligent motor control by the Australian industry? So maybe we might kick off, Dippy, with yourself.
Sure. Thank you, Michael, for that question. That's a very good question. I think that's pretty much the purpose of our webinar, to try and encourage more of intelligence, to have the benefits of what intelligence does, not just in motor control, but also other aspects of the electrical systems and power distribution and others. I would probably answer this in two different ways. So one is, I think there's a bit of a practice of doing things in a certain way. So we do get used to certain design aspects and certain systems the way they are catered to in the past, and we continue that format, which may or may not always involve intelligence. The other bit is also technology. So when it comes to technology, I think embedding intelligence in a system in the past has been expensive. So it's pretty much kind of a step up from a basic level of motor control all the way up to having all the data and analytics. And there was nothing which was in the middle, or something which created value for, let's say, plant owners, or people who are investing money in such installations. But I think with ABB Solutions, we have come a long way, and our R&D continue to work on a daily basis to create new solutions, to try and find the balance between scalability and future expansion, which is where we are trying to move towards future-proofing our system. So how that works today is that we have a basic system which can be upgraded not just through hardware, but also through software, to have features which can be unlocked in the future by users. And that's aiding this change. So in terms of barriers, I guess there's a bit of cost involved in that. So initial cost or capex that comes in the beginning of a project, which needs to be considered. Maybe it's not always clear what's the benefit of investing more money versus what we really benefit from in the long term in energy savings and other things. And the other aspect is technology, which is not in steps, but it's kind of scalable over a period of time or period of the installation itself. So that's my view. I don't know if Lee, if you have any comments to add to that from a systems perspective, feel free.
Sure, DP, thank you. So I do actually have a few words to add on. So for the concern of the high initial investment using the intelligent motor controller, this is quite often heard from our customers. Yeah, so I fully agree with DP's opinion that this should be addressed from a complete, like the whole life cycle, that considering the return of investment. What I would really like to point out here is the CAPEX cost. So using the smart motor controller today should also consider from a complete MCC solution perspective. So as we mentioned in the presentation earlier, today's intelligent motor controller compared with back in 1990s cover a much wider range of the functionalities, while the physical dimension these days is much more compact. But also it's quite flexible and easy for installation as well. So for example, a separate HMI panel design from the main device or the detachable communication interface. These days are all possible idea and support remote installation, so make it a lot more flexible in terms of installation space. So as a result, the footprint of the intelligent MCC, conventional MCC, can reduce and help to offset the capex gap. So will ease the concern to a certain extent. Another noticed of is the concern of the reliability these days, or in the past of the intelligent motor control, especially under the load control condition, or the harsh environment. So again, I would like to mention that today's microprocessor technology is not the same anymore and has already reached a maturity and stable stage after more than 30 years exposed to the market. So given the example again from ABB's motor controller, UMC or M10X, we are looking at the devices are designed to be really robust and reliable. So with a minimum of 30 years mean time between failure value and sustain very high operating temperature. In the same time, we have the optional anti-corrosive coating design and SE and seal rating levels options, etc. So those are all catering for today's application across all the industries. Yeah, this is my
Excellent.
contribution. Back to you, Megan.
Thanks a lot. Thank you both. Dippy, I've got a question which has come through from Justin, and his question is: what are its failure rates? So, what is the failure rate of ABB motor starting solutions, and how is it measured?
Thank you, Justin. That one has multiple answers because it depends on the kind of product we're talking about. So we generally measure our products in MTBF and MTTF, which is mean time between failures and mean time to failure. And there's a formula we apply, which is over a period of time to say that when these values are released, and we declare those values. They are very different for different products. For a soft starter, it'll be very different from a contactor to a circuit breaker. So it totally depends on which product we're really speaking about. The timing is different, but we do issue those values based on project requirements, and we're more than happy to help you if you have further questions on them. Thank you.
Thanks, Dippy. Hussein, I'll bring you into the conversation. And we've had a question come through, and is what is IT OT convergence, and what does it actually mean to the electrical system?
Hi. So this is very interesting question. I mean, we are living in a time where we have internet growing. The speed is amazingly increasing by manifolds from year to year. So IT and OT convergence means that what used to be the conventional part of the information technology is now getting merged with the OT, which is operation technology. And I would say the main drivers are the fast speed of internet and increasing number of internet users and the devices. Just to give you the flavor from different reports, we find it out the number of internet users in 2023 has increased to 5.4 billion as compared to 3.4 billion from 2016. Similarly, the speed of internet has increased from 7.2 megabits per second in 2016 to around 46, 49 megabyte per second. Another interesting thing is we are seeing cell phones, smartphones are getting very common, and another study shows that the number of cell phones were 4.4 billion in 2017, and it will be around 7.49 billion in 2025. So combining this high speed and availability and easy access to internet has increased this convergence. And for us, being automation people, it's getting even more important because what is happening that we have data available. Now the question is what to do with those data. So we are capable of getting data over high speed internet, like what we have seen, and then at the same time, this will help us to gather those data to find out breakdown times before they occur, and then also more proactive maintenance, and then avoiding costly downtime. Another aspect is actually if you adapt some digitalization, if you adapt some monitoring of your devices, this will not only help you understand the breakdown times, avoiding making better proactive maintenance, but also this will come up with a new innovative idea that how can I have the data, and with the data trends, the company will be able to find some innovation method to optimize the performance and flow and efficiency of the devices. Not to forget energy efficiency. We have seen motors, so they are consuming 47% of the worldwide energy consumed. So combining all this thing is very important. And I would suggest with ABB, let's start something very small but very smart. Start with a small part of your plant, get it connected to the cloud, monitor it, and then you will find yourself that, okay, by doing simple monitoring, you are able to see different trends, which will enable you to even make your process and performance even more efficient. Thank you. Back to you, Megan.
Oh, what I might do is move on. Hussein, you dropped out for a moment there, but I am looking at the time, everyone, and we are running out of time incredibly quickly. I think we've only got probably a chance for one or two questions, so I might throw to some of the live questions. And apologies, there's so many coming through. But Lee, a question came through from Shah, who's watching live. And the question was, are all ABB switchgears, are they having Modbus communication built in?
Yeah, I can answer that. As we mentioned that this is actually related to intelligent motor control centers. So for intelligent motor control centers, ABB's strategic is built on the smart motor controller devices. So smart motor control devices we mentioned before for ABB's product is UMC 100, the 3 or M10X. They both have Modbus built in, and either it's Modbus RTU or both the Modbus TCP, which is the Ethernet-based one. And for the Modbus RTU, the Modbus network that is supported by switchgear is usually the daisy train, the bus or bus connection. But for the Ethernet base that we support from start wiring to bus wiring and until to the redundant ring structure. Okay, back to you, Megan.
Just to add very
Thank
quickly,
Oh, yes,
is
please.
something like I'm sorry for that. All of our devices are being supported by Modbus TCP and RTU when it comes to connectivity. We provide gateways which are capable of getting devices connected over Modbus RTU and TCP, and in fact other protocols for sure. And then they are capable of sending data to the cloud for better performance and analytics. Yeah. Thank you.
Thank you. Look, Dippy, did you want to have a final word? Because I think we've run out of time today with our Q&A. Did you want to maybe just have a final statement to the audience with regards to the questions that we didn't get a chance to cover, but we definitely have them listed. So I'll just quickly hand over to Dippy.
Thank you, Megan. Sure. I see a lot of questions as well on the live questions coming up, and they are all very interesting questions. Unfortunately, the time doesn't allow us to really go through and conclude those questions. However, we will definitely get to them. So we will register them. We have all of them noted, and we will come back to you with specific responses. Also, if there's a discussion that's to be had with us, we are here to talk about the various topics, whether it's harmonics or whether it's cloud connectivity or cybersecurity or any aspect which relates to data and analytics or motor control in its basic format. So we're here to talk about it, but we will definitely get to the questions as soon as we're done and as soon as we can. But thank you everyone to listen to us. It was great to have you, and hope we have done justice to your time, and have a nice day. Thank you very much.
Thanks, Dippy. Look,
Thank
on
you.
behalf of all of us, I'd like to thank everyone for our speakers, I should say, for their time. So Dipiman, Basu, Hussein, Hamed, and Lee Chen for their time and input today. I'd also like to thank Engineers Australia's industry partner, ABB, for their support with this Thought Leader webinar. And if I could please ask everyone to complete the short feedback form, which is linked in the description box below, is by completing that, it really does help us to ensure that we're improving and delivering valued future sessions for you all. So finally, and we also last thing I should remind everyone, we've got our Climate Smart conference coming up. So we have the Climate Smart Engineering Conference happening here in Brisbane on the 22nd of August. So early bird registrations are now open. So please jump on board and register for that exciting conference. So finally, just wanted to say thank you to you, our audience, for joining us today. And we hope to see you at our next Thought Leaders event. Good afternoon.